When doing multiplication, we don't have to worry about going to the same place value. That's right, when we're doing multiplication, we don't have to worry about the same place value. So, if I start with a problem like this, 191 times 11, what am I going to use if I'm not using the same place value? The answer to that is I'm going to use my leading digit. Your leading digit is exactly what it sounds like. Your leading digit is the most left number, the first digit in the number. So for 191, it's the 1, and for 11, it's this one. If we round to those digits, I round 1, I look to the number to the right of it, it's 9, which is greater than 5, so my new number is going to be 200, and then I'm going to multiply that times, we look at the 1, we look to the number to the right of it, that's 1, which is less than 5, so we round down to 10, and then all we have to do is our simple multiplication. 200 times 10 equals 2,000. Pretty simple stuff there. Again, let's try one more problem of multiplication. So, let's try the problem 357 times 23. Again, we're looking for our leading digit because it's multiplication. So, our leading digit here is the 3. Our leading digit in this number is the 2. Look to the 3. The number to the right of it is 5 or greater. So we're going to round up. So 357 becomes 400. We're going to multiply that times, let's look, 23. 3 is less than 5, so we're going to round down. So we're going to multiply that times 20. And 400 times 20 is 8,000. Alright, guys. Now, for whole number estimation of division, we're going to do something completely different. We don't have to round to the same place value, and we don't have to look for a leading digit. Rather, what we're going to try to do is we're going to try to round to compatible numbers. Let me show you an example of what we're thinking of here. So, for example, I'm going to use the number 191 divided by 17. So, normally, if we were doing addition or subtraction or multiplication, we would be confined by rules of looking for leading digits or rounding to the same place value. But here we're looking for compatible numbers, and you're going to want to put that in your notebook. Compatible numbers. And what compatible numbers are very simply, compatible numbers are numbers that work well together. In other words, numbers that you can use, and they're going to come up with a simple answer, usually that you can do in your head. So I found the best way to work with compatible numbers is usually to round your smaller number first. So we'll start with 17 here. And let's round that to something nice and easy. If we round it to our tens place, we have 1 here, we look to the 7, it's going to round up, and our new number is going to be 20. So we're going to divide by 20. We know that for sure, but let's look at our first number here. Okay? Now, what we're doing here is we're looking for the number that 20 can go into nice and easily. Simple mental math if we can at all do it. And I'm going to look here, and what I'm thinking right now is looking at 191. 191 is pretty close to 200. And you're absolutely right. 191 is close to 200. Now, if we had rounded to our leading digit, we would have got that 2. If we had rounded to our tens place, we would have ended up with 190. But I'm looking at it, and between those numbers, which one of those numbers is really easier to work with? Does 20 divide easily into 190, or does 20 divide easily into 200? 20 divides easily into 200, giving us an answer of 10. So that's what we're looking for. We're just looking to make compatible numbers that allow us some easy mental math. Now, I know some of you are going to say to me, but Mr. Brin, what about over here? Doesn't 191 also seem pretty close to 180? And I'm going to say, you know what, you're absolutely right. But if you look, if we make a little number line over here, and we have 180, and 200, in the middle there, we're going to find 190. And which side of that middle line are we going to find 200 or 191? It's going to be right about here, just past the 190. And remember, when we're rounding, we're always trying to be as accurate as possible, even though we're looking for an estimation. And because 191 is closer to 200 than it is to 180, 200 is going to be our choice. So let's go back and let's try one more problem working with compatible numbers. Trying one more problem, we're going to work with 587 divided by 26. So again, we're going to start with our smaller number, 26 here. And rounding 26, let's go up to 30, just because that's kind of normally what we would round 26 to. Now, what is a number, and most you can see just looking at it, you can take a quick guess here, what's a number that's close to 587 that 30 would go into evenly? Now, one jumps to my mind right away, and that is 600. And you can see how 587 is really close to 600. So then we divide 30 into 600, and what are we left with? 20. All right. So just to sum up, compatible numbers, we're not following any specific rules of rounding to the same place value or rounding to leading digits. All we're looking for are numbers that these numbers are close to that work well together to give us some simple mental math. Great job, guys. Remember, if you have any questions, watch the video again.